Hello, everyone, and welcome to this webinar, Telit Security, Secure Device Onboarding and IoT Deployments, Part 1. I'm Amanda Flink, Head of Global Events here at Telit, and I will be your moderator for today's event. Before we start, we'd like to gauge an idea of how your company assesses cybersecurity of solutions and systems for your IoT projects. If you could take just a second to fill out our poll question, which you should see on your screen now. Okay, now let's get to know our speakers. To explain this topic today, I am pleased to be joined by two Telit speakers. First, we have Dr. Mihai Voicu, VP IoT Services R&D and Security Technologies at Telit. Second, we have Martino Turcado. Martino is the Head of Software PM at Telit. Just before I hand it over to Martino to start the presentation, I have a few quick reminders. I would like to encourage our audience to interact by posting questions. We will have time to answer some of those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out the presentation slides and a replay link to all attendees at the conclusion of this webinar. And with that, Martino, I'll hand it to you.
Thank you, Amanda. Hello, everybody. So today, we are going to give you an overview of the main security considerations and challenges for solution providers, and how at Telit we are trying to help our customers overcoming these challenges. Cybersecurity is essential in our businesses and also everyday life. And it's widely recognized that the Internet of Things makes cybersecurity even more crucial and also more difficult to achieve. And the philosophy of these webinars is to gear towards a more practical approach to some of the hottest topics around IoT security. But let me first start by looking at some key numbers extracted from recent researches to provide with some context and background for the concepts that we will introduce later during the presentation. So in a 2020 report from Beecham Research on why IoT project fails, and when exploring the importance of technical and business challenges in successful projects, security represents the most significant challenge from a technical perspective. And the same view on the IoT security is confirmed by Microsoft in its IoT Signals research from last year. In this case, we have an even more striking result with 97% of companies concerned about security when implementing IoT. The trend is stable and confirmed. According to Beecham Research, security has consistently scored the highest among concerns over the last 5 years. And in the Microsoft research, the top scoring concerns fall into four main areas: the software and firmware management, device management, accounts and authentication, security training in the enterprise organizations. In the context of security, software management is there to ensure that the software, the firmware, and the encryption protocols and security in general are up to date. Securing devices is also strictly linked to provisioning, monitoring, remotely managing those devices. And additionally, IoT adopters need to establish proper authentication of assets and protect credentials to ensure the trust of data and reduce the risk of data breaches. The good news is that despite the rising concerns, security is not perceived as a top barrier to using IoT. And even for those with significant security challenges, IoT is considered worth the investment. Along the same lines, this report from McKinsey. So cybersecurity has become central to value chains. in many sectors as organizations are increasingly exposing data and strengthening their connections with customers, suppliers, and other business partners. And this is making security the most important factor to consider when purchasing Internet of Things products. Leading companies are therefore starting to build cybersecurity into their customer relationships, production processes, and supplier interactions. Well, all this data looks pretty good compared to what we were seeing from our angle in the market 5 years ago. However, various surveys still indicate a significant gap between the perceived priority and the level of preparedness. End-to-end security across the entire IoT solution and value chain implies that along with the evolution of solutions, the security must be maintained, must be evolved, and adapted, since it is not a one-time activity. It's a process. It's a journey for the entire organization, and this is inherently challenging. So why are companies' progress regarding cybersecurity implementation not fully aligned to the magnitude of the threat? Some of the main reasons can be easily identified if we look at some common challenges for the solution providers. So the shift to digitization is an inevitable transformation that is driving all the enterprises. But along with the benefits of such changes, there is an increasing tension between the business's needs and the security challenges of the organization. Decision makers frequently overlook the impact and the cost of security aspects involved in this process. They usually continue to think of a cyber attack more as a possibility rather than a likely to happen event. But starting from the assumption that a future attack will happen and will degrade or destroy key infrastructure or the key functionalities of the service, the stakeholders can take actions in advance to build resilience into their systems. Low preparedness might also be linked to an insufficient budget allocated to cybersecurity in the IoT. It's essentially a matter of prioritization. But if we consider that sometimes not easy to make the business case for IoT initiatives, allocating a budget and making the case for a solid security strategy is even more difficult. Companies are primarily rewarded for features, for the price of their products, for the time to market. It's easy to take security out of the equation if it's not an evident need or a compliance requirement. Designing and implementing a secure solution also requires special knowledge, and companies need cybersecurity expertise and technical skills, which involves a mix of traditional IT knowledge, but also operational technology aspects. And while in the past the number of endpoints in a large corporate network would be somewhere between 50,000 or 500,000, with the IoT, we're talking about millions or tens of millions of endpoints. And so cybersecurity attack vectors increased dramatically. Organizations must also understand what IoT security will mean for the specific industry and the business model. And so security solutions need to be tuned in to the specific use case. If we look, for example, at the needs of industrial IoT environments, they face unique challenges. Given their distributed, decentralized structures and large OT, operational technology environments, this is a scenario that is not suitable in most of the cases for traditional cybersecurity controls. We also have to factor in other requirements, such as the mission criticality of processes involved and the need for continuous availability. Enterprise also need to simplify and strengthen processes across the value chain to reduce vulnerability and control the costs associated to the need of specialized personnel and the training. Also, a mature solution must be able to reduce the burden on the enterprise. This allows to offload some overhead and make the problem more tractable. Also, you need to build security directly into value chains and business processes to guarantee a continuum of security solutions. Also, the lack of integration in security and privacy elements is introducing complexity. Responsibility and ownership within the organization and within the many different players usually participating in the solution ecosystem is another aspect to be considered. Security needs to be part of the entire product lifecycle, starting with the product design, the so-called security by design approach, moving through the development process, the production and manufacturing, the commissioning of the devices, and then continuing each day the service is active and in use. And this is done by monitoring and maintaining the deployed assets. So security cannot be an afterthought, since all the security capabilities that are bolted on are inherently less effective than those built in by design, or can even negatively affect the user experience. Enterprise must identify and manage the risk associated to massive data sets and sensitive information. A research from McKinsey is reporting that about 1/3 of the breaches in recent years have been attributed to insider threats. This risk can be mitigated by ensuring that those data are accessible only to those who need them, and that critical information are not exposed throughout the product lifecycle and the business process. Finally, using the standard-based solutions is always the most recommended approach, since many of these technologies come with a well-defined security model integrated, and the framework is constantly reviewed and updated by the ecosystem and the industry organizations. And on top of that, especially for some sectors, security solutions must comply with current and upcoming legislation. And to conclude my first part here is a list of the most recurring considerations. And just to mention a few and the most relevant, securing communication in the network is crucial. And this involves various pieces, including authentication and encryption. Managing identity of the asset is one of the most painful aspects, both from a technical and logistical point of view. But it's also an essential aspect in order to trust data and operation from the elements and the nodes that are composing the solution. Device management, so the ability to monitor and remotely manage a device is critical as well, along with the need to provision and update the configuration of the device. And in the context of device management, software updates are paramount to guarantee that patches and enhancements to security are correctly tracked and delivered to the endpoints in field. So with that, I'm done, and I'm handing over to Michael, that will provide more details on secure solutions.
Hi,
Thanks,
everybody.
Martino. We want to pause for just a moment here before we hand it over to Mihai to take just another quick poll. If your solution uses a cellular module, do you prefer to have a root of trust in the hardware or in the SIM card? All right, thanks. Mihai, see you.
Hi, Amanda. Thank you very much. Martino, for the introductions. What we're going to do today is we're going to try to build a strategy. And for that, we would like to bring a couple of things into the picture. First of all, as you can see here, we have the main blocks for an IoT solution. First, we have an edge hardware. That solution will need to be close to the sensory data and also has to be close to where the data is captured. There will be interfaces that needs to be developed. There will be protocols. And most of the times in this particular example, like an industrial architecture, there are a combination of activities done at the edge that are really, really the most important part to extract the information. After that, we're going to see the communication path. This is most likely a network from a cellular to Wi-Fi to LoRa to anything that actually can communicate between. But the next block, and these blocks are not in a real sequence, but somehow you can see that they are relevant and they are connected to each other. We are talking about the software and the cloud. This is the piece where all data will be aggregated and all the sensors will make their end sending their information here. The importance of the software and the cloud is you have the ability to manipulate this data as well as combine it in such a way that represents a single type of data or a single view of the data. The last part in an architecture for IoT is application and services. At the end of the day, the important part of an IoT solution is to gather the magic of the business. This is where everything is happening. You really want to analyze the information that your sensors are sending to you. And you want to take business decisions in such a way that you can return value of what you've invested. In the same time, you want to have the ability to do business operations in such a way that they will maintain the health of your IoT solutions. So, how do we see all these blocks in a security context? So let's start building up this context. First, this line that you see, it's a manufacturing. It's very important to understand how you manufacture everything from a security point of view. How the hardware is manufactured, how is the software manufactured. You want to make sure that you know where your software is coming from. You want to know where your hardware is coming from. In the same time, you want to know how are your facility for manufacturing both the hardware and the software. And all of them will give you a perspective of how your manufacturing facilities are placed in a security context. In the same time, if you take a look to facilities, are your manufacturing facilities operating under certain certifications? Do you know these certifications? Are you part of the certifications? Are you a vendor of this for that? In the same time, you want to look at the software side, and we're going to dive a little bit deeper later on into this. And just an example, do you use the correct libraries when you build your software? Do you actually understand the impact of the libraries on the overall solution? Do you actually put all the right software into your solution. So this is the context. We are building an IoT architecture, and you have to take a look of how the security is built up on this. Let's take a look at the next part of this: communications and protocols. All the solutions will have different components. Will have different elements that will interconnect and communicate to each other. Do you know how your VPN set up? Do you know how to use APNs for a cellular communication? Do you really use protocols that are secure, or you need protocols that are not secure? This part of its infrastructure that is required to build your architecture, but it requires to pay attention to all these little details. For example, just at the end of the day, mutual authentication. Do you do mutual authentication for the HTTPS or for any of this? So simple things like that are making a big difference in how this architecture is built up. Do you, for example, use proxies? Do you use, for example, TLS encryption, and you know how it's terminated and who actually has access to the keys? This is part of the architecture again. Another piece, we're going to build up system operations. Who actually, and what is the meaning of that? Do you have a specialized team that does secure operations for you? Where is that entity? Who has access to it? In the same time, do you know what's happening with your information at rest? Do they have access to the databases? Do they control the images with pre-built image? Do they actually know and have a good change management in place? Do they have access, for example, for the firmware that needs to reside on the hardware? Do they have access to the source code? Do they have access to the builds? So all of them are very important when you look at the overall health of an architecture like that. Also, a little bit of gotchas here. Do you have, for example, when you transfer the firmware that needs to be placed in the end device, is that firmware encrypted? Is it encrypted in transit? How many places is at rest? How do you actually have them positioned in the rest when it's at rest? More into this, it's very important and critical. For example, in some operations, what is the difference between IT and OT? What is the entity that's running your productions? Do they have access to the file system? Do you actually have security certifications for these operations teams? Do you perform risk assessment that are allowing you to know the health of your architecture? So those are questions. Those are important questions that you need to answer. So next on this list, we have business operations. Business operations is what I call it, the business of doing actually business. Do you know how to provision your devices? Do you know how to build them and how secure is your billing? Do you know how to do it and transfer it? Do you actually perform onboarding and also have photo capabilities so that your edge devices are really up to date? And not only that, you perform them in a secure way. In most on the photo part, who's generating your delta? Who's actually giving you the ability to know where that photo delta is residing and how is it transferred to the devices? And later on, I'm going to build on this, and you're going to see how we do this. The last part of this architecture, it's a security part architecture, is the identity and crypto. In my view, this is the most important part, and there are elements here that everybody should be looking into if they want to build an architecture. One of the most important questions that I always been asked when it's relevant to a hardware device is, do you have an identity for that device? Do you have an identity that is immutable? Do you have an identity that when an RMA is happening, or when there is a reflash, or when it's a remanufacturing, is that remains the same, or is changed? What's happening with the previous identity? So all of this needs to be answered. Also, in the same time, do you have the right encryption and decryption? Do you actually encompass libraries that are well known, that are producing encryption and decryption that is relevant? Also, in the same time, do you actually want to use trusted execution environment? Do you want to use them in such a way that is fulfilling some of the questions that I have here? What is actually the right way to access this TEE? There are so many questions at this moment that if I have to list them, I have the next slide. So basically, I just put them here, all the questions that in our view of securing a solution have been bothering us for the last couple of years. This is mostly a checklist for everybody. I don't think it's comprehensive. I think this is just the beginning. And if you want to look into your IoT solutions, you should start with these questions. They are relevant, and most of the times you have to answer them. So, at the end of the day, these are a lot of questions. And you have to have a lot of answers. If you are a business owner, all that you really wanted is to eliminate the complexity of the security and the requirement for expertise. And in the end, all that you wanted is some data, sensory, to be transferred into some application where you can make business decisions. Or you want to have a trigger, for example, an alarm when some temperature is reached, or you want, in some cases, to manage your devices and understand the health of your devices. This is what it's all about. So at the end, it's complex. So how do we see this? How do I, as Telit, look into all these questions and look at how to provide a different angle? Our pillars for security in terms of architecture and building it up were driven by these three elements. It's about value, it's about vendors, it's about technology. You can see that this is not really different than a normal business pillars. And if you look correctly, the value is where you want to have a good solution, where security is giving you an edge into your business. The security is something that you have to put it out there for your own customers and make sure that they understand it. Second, the vendors. You really want to partner with the right vendors for this solution. You want to have them around you. You want to have them as a proven partners to you, and you really want to make sure they will be there for you when you are in trouble. The last part is technologies. When you actually look at technologies and how to employ technologies, you have to bring them into your architecture by the risk attached to them. you have to have the knowledge of how that technology is benefiting you into your architecture and into your strategy. So all this triumvirate of value, vendor, and technologies are the guidance principles that we move forward into our strategy from here. So moving forward, what we did at Telit, we actually look at all the slides, especially the first part, the first slide, where we had all these 4 blocks, and we tried to simplify it. So what we said is, we have in one side the sensors and the other side the applications. We want in the middle to create an ecosystem, a secure IoT ecosystem that will give our customers the confidence that you have the right partner in terms of a vendor, you have the right technology as partnership in what is to be done, and at the end, there is the value that we invested, and you can see it when it comes down to security. So, that being said, let's take a look of what Telit have built up. And we're going to start with a blank page. And this will actually give you an idea of how do we answer the questions that were presented to you earlier. What I want to do is basically a journey into this strategy and how we actually build one by one all the elements that are required to take away from our customers a lot of the complexity of the security. So let's start simple. This is basically depicts the network or a cellular network, because in our case, I'm going to build it up around one of our main devices or our main products, ME9. And at the end of the day, it's important to know who are your partners into the network connectivity. You have to make sure that you have the ability to trust them and you have the ability to adapt to their changes, and also they will actually understand your needs. It comes down from connection as VPNs or the ability to have specialized APNs. You have to have the ability that they have a very good network operation centers, they have a secure operation centers. But in reality, this is part of the ecosystem. Next, what we build in Telit, and it goes back to the last line in the first slide that I presented, is about crypto and identities. What we did in Telit, we created a credentials warehouse. It's a solution and that we store every key that we need to actually share in between our IoT platform and the device or the cellular device in this particular case. This is basically where, for example, let's take an example of Lightweight M2M credentials, which we're going to talk a little bit later. If you are not familiar with the protocol, you're going to understand. In the second part, we're going to discuss a little bit more about this. But the Lightweight M2M protocol requires, for example, the DTLS part requires a pre-share key. Pre-share key needs to be set up already at manufacturing and also needs to be set up at in our Bootstrap servers. Somewhere needs to be the manager of these credentials, how they are generated, how they are stored, and how they are propagated if there is a need for that. This is the place. We build it into it, and also we have the ability, for example, here to generate root certificates in demand for our secure boot, for our signatures, for firmware signatures, or for FOTA signatures. We have we have a lot to store here, and also it's an entity that backed up by HSM. So everything that is in this warehouse is stored. Now, also this warehouse provides APIs that allows you to interact, and all the parties that are receiving or are moving information into this warehouse have the ability to, they are always under mutual authentication between the components. What we did is basically in our facilities. For example, in our facilities, for secure firmware provisioning, we transfer the firmware, using only encrypted channels. Each firmware is signed, and only after the signature is verified is actually written into the flash of our ME910s. We use also root certificates for that, and also certificates that will give us the confidence that the information that we actually use is ours and it's not been altered in transfer. That also has capabilities to make sure our firmware has a secure boot included on that. In the same time, our manufacturing facilities have secure key injection. We've been talking about the Lightweight M2M credentials. When you communicate with a Lightweight M2M bootstrap server, there is this need. So all our secure Lightweight M2M keys and many others they will be injected in our firmware based on local identity and the security attached to the certificate. Also, all this information in the manufacturing is backed up by the HSMs, so that we can have the confidence that we know what encrypts and when it's encrypted, and not only that, the decryption mechanism is happening in such a way that we control it. In the middle of our solution, we have our IoT platform. From a security point of view, we have a Lightweight M2M server that actually has a bootstrap. It's an application server and a bootstrap. We have a Lightweight M2M credential inventory. For that, basically, we have ability to provision our modules on the field. Also, in this platform, because we are talking about security, you have to think that the platform comes already with secure protocol injections, with authentication of the authorization, and also with MFAs and all these goodies. I should call them at the end of the day. Another example of what we built in our platform is the ability to send secure AT commands to the module based on the key that has been pre-shared, and it's unique for each of the modules, and also these keys are stored in our warehouse. Sometimes this platform has the ability to do photo campaigns. Each of the campaigns are in such a way distributed. They are distributed, and we use an engine for propagating the delta for the photo to the relevant modules, and each of them is encrypted with their own specific key. Also, the platform has the ability to send secure SMS commands. We have developed special technologies for that, and that will give us the ability to send commands to the module in such a way that will allow the platform to interact with the AT commands that are relevant in the module. Also, at the very core, all the database behind the platform are encrypted, and we use, for this particular, because our platform is in AWS, we use a cloud HSM that is really very strong and doesn't allow us to export any keys, and all the crypto operations are done in the HSM. The last piece, and I call it the piece that actually represents the important part of this ecosystem that we create, is the module itself. This is a new module from Telit, ME910, and each of these modules have a hardware-bound unique identity. Different from the serial number, different for the IMEI, different from a SIM ID. This is unimmutable and cannot be changed to reflashing operations. We are using also LivePerimeter client, and by default it uses DTLS. Also, each module uses the Qualcomm Trust Zone for crypto operations, and each operation is performed accordingly regarding encryption and decryption. On top of that, we developed secure APIs, and more of this will be part of the second webinar that we present. And I'm going to go in more details then, and I'm going to show the secure APIs, 80 commands, and also I'm going to show how we secure storage information to the modules. And also I'm going to explain how we actually build the SIMWARES on top of this powerful set of APIs and secure commands for AT. On top of this, all this interacts together. That will give you actually an ecosystem where the majority of the questions that we put there, all the questions that we put them up there will try to be answered. That's it from me right now, and I'm gonna give it to Martino, and I think Amanda has another poll, and let's see. Thank you very much.
Thanks, Mihai. Yeah, before we get back to Martino, we're going to pause one more time here for another poll. Would you use a cellular module that would offer encrypted storage as well as crypto functions based on zero trust versus application-level encrypted storage or crypto functions? And with that, Martino, I'll hand it back to you.
Yeah, so in the next couple of slides, I'm going to give you some more details on our offering and how we are trying to address all these different challenges in our product. But in order to position, to better position our offering and understand how this is mapped onto real products, I would like to introduce first the concept of first mile that we coined at Telit. In the telecommunications and internet space, bridging the last mile usually means bridging the final connection from the curb to the customer premises to send data and content from the central server to the edge. But in the world of IoT, this logic is reversed since IoT starts with the edge and the data generated at the edge. Stating the obvious, if data can be read by the analytics platform, there's little value in IoT. And getting a device to talk to large-scale data management, analytics components, applications, is the hardest thing, especially for companies mainly focused on the IT side of the problem. And usually they need partners and integrators to help them to take that advantage of those data. And this is the mission we have embraced at Telit. Our mission is helping these companies cross this first mile, simplifying the remote management, the connectivity, the data collection, and the delivery to the enterprise applications in an efficient and meaningful way. We have already seen this diagram, but if you start from the left-hand side, you can walk through the main components. So you have the edge hardware and with the sensors and actuators and the devices that are leveraging networking capabilities from a wireless module or a gateway. Then data is exchanged over a cellular wireless connection. And after that, data is processed and reduced by the middleware and the platform, where we provide also device management and connectivity management functions and connectors. In the final stage, which is the enterprise system, data that has been processed, integrated, and analyzed is used to power analytics and applications. So One Edge is Telit answer to bridging and managing the first mile. One Edge is basically an integrated suite of software components and services, and it's been awarded six times since its launch. With One Edge, when we talk about One Edge, it's the classic make or buy decision. With an integrated solution, we can start shifting the paradigm from the make approach, where a solution designer has to take into account various components from one or multiple vendors, understand those components, and be responsible for the development and integration. We can shift to a buy and configure scenario where all the components come pre-integrated, pre-tested, and the main effort for the customer is to configure them and extend where needed. This circle is representing the framework that describes One Edge. It's also a framework that is a good representation of the aspects that a customer must deal with when designing an end-to-end solution based on the cellular technologies. There are five main pillars to One Edge. Device management, which relates to the installation and configuration, the remote management and the monitoring, the troubleshooting, and the software update services. Device management is a key factor to sustainability and scalability of IoT deployment. It's essential to guarantee QoS of a solution. And on the importance of the standards, I would like to emphasize again the fact that One Edge, as Michael mentioned, is based on Lightweight End-to-End protocol, which is a centerpiece technology in our solutions, and is also gaining an increasing footprint in the market and other solutions. Then we have Edge Intelligence, which includes functions and tools to program the behavior of the device, manage the local sensors and peripherals, send and receive data to server on a secure channel, and also allows to simplify some activities like managing the cellular connection. Cellular connectivity management includes the integrated SIM and the connectivity management service on the portal. Next item is the enterprise integration. This is including the tools needed to facilitate the integration with the enterprise systems and business processes of the customer. And of course, we have security, which is one of the most important areas in One Edge, as you understood. This is related to the end-to-end encryption from device to transport to cloud, but another important aspect is the pre-provisioning and the personalization at manufacturing time. This is done to not only to increase security, but also to simplify the user experience and the initial installation and onboarding without exposing security assets and avoiding manual configuration of devices and IT systems. Just to summarize on the personalization aspect, as we said, each module is provisioned with a unique identity, which is immutable, which is used for tracking and auditing modules across the various systems. And this identity is shared with the Telit Platform for device management and Lightweight End-to-End connectivity. All One Edge modules support secure boot, and so the firmware is signed and relies on a secure root of trust. For the modules supporting integrated SIM, the modules are coming with a SIM-OS preloaded in production with a set of specific specific profiles. We also provide trusted execution environment-based crypto microservices that you will see in the demo. So it's basically an abstraction layer for the crypto operations to manage secure storage areas, to expose some encryption and decryption APIs, and all the security functions are performed inside a secure environment which is separated from the user space. One last note on the out-of-band communication that we provide by means of SMS transport. So we can create encrypted SMSs based on the personalized keys and that we can use in emergency cases to send a command to the module. And each message is specific for the module, not generic for all of them, since it is based on personalized keys. And also these keys are inserted into the module in our manufacturing facilities and securely synchronized with the platform. With that, I'm done on the overview of OneEdge. Handing over to Mikhail for the conclusion.
Okay, so what we're gonna do next is basically we're gonna give you a little bit of a preview of the second part. What you see here is our sales kit demo. This is a unit that encompasses almost every technology that we talk about in the last few minutes. What we're gonna do, we're gonna take you to a journey of what's inside of the ME910 from a security point of view, how actually we're gonna do a secure manufacturing for this from a point of view of keys. We're gonna go after that into a journey into the IoT platform and how this particular device will be provisioned and where to look for it into the platform. And at the end, we're going to talk a little bit about the SIM-WISE. SIM-WISE is basically a seamless connection that Telit provides. And you can see here, and I'm going to actually turn on this. This is a video. This unit in particular doesn't use a physical SIM, and you can see that the holder doesn't have anything. And in a couple of steps, basically the LED will display all the information happening. It's a little bit too small, but you're gonna realize the steps accessing the network, from that establishing a PDP context, and from that it's basically going into the platform and sending information. All this, what you see here, basically there are one or two buttons, the power, the I/O, and a couple of LEDs. There is a sensor, humidity sensor, there's a temperature sensor, and all of this can be accessed. And next week we're gonna see them actually propagate this information to the platform. At the bottom, you actually have an example of two new AT commands that Telit has been built into this module. One of them, it's a TID. Basically, this is the unique identifier, an unmutable unique identifier that Telit has been built into the module, so that, as Martino mentioned a couple of times, we can base all our activities in relation to this ID. This can be used for multiple purposes at this moment. And the second command is an AT-SecK. It's basically a command that generates a private and a public key. The private key is set up into the trust zone, a Qualcomm trust zone, and this command exports the public key outside for usage. And you're going to see how we're going to use this key to actually transfer information into the module and secure that information into the transfer. That's all next week, and we're going to get a little bit more hands-on to these commands. We're going to explain the list of them, and we're going to actually have some good direct activities into the module. And with that, I will hand it over to Amanda for the last part.
Thanks, Mihai and Martino. Before we get to the questions, I'm going to drop just one last poll here. If you would like to have one of our experts contact you, please respond here on the poll and we will have someone reach out to you. We now have time for just a few questions, and there is still a few minutes to ask a question, so please submit using the box to the right of the slide presentation, and we will do our best to cover it. It looks like we've gotten a few. First question, can these approaches be used for ongoing device authentication and security checks during device lifecycle and usage, or is it just for initial activation and onboarding?
Hi, Amanda. I'm going to take this question. This is a very important question. There are cases where ongoing solution can be adjusted to have an increased device authentication. It's all depend on the risk and how the risk you want to be calculated. This risk needs to be accepted by the business. Now, the best solution will have to be where the devices are born with the right identities. So that can be used for the device authentication. That will create a very powerful root of trust for devices and will be easy for everyone to leverage that moving forward. That's why we at Telit, we emphasize on creation of this new AT command called TID, which basically stands for Telit ID. And with that, we can create a device authentication for new modules. And that's, as I said, it's a much better solution. For old ones, will require some adjustments. Handing back to you.
Great, thank you. Another question we've gotten, how does the secure onboarding of devices vary by IoT platform and network protocol?
Okay, I can take this. Although it's not easy to give an answer that covers all the different scenarios. What we see in the market is a variety of solutions that are either based on proprietary implementations that are taking advantage of some secure protocols, such as TLS, or standard-based solutions which relies on a well-defined security framework for security and onboarding. So this is the case of lightweight end-to-end, so focusing on what we have implemented as part of 1H and what you're going to see in the next webinar. In lightweight end-to-end, main operations of onboarding go through the following steps, and these are well defined by the standard. First, the device sets up a secure connection, typically based on the TLS. But TLS is supported as well. This can be done either using PSK or certificate-based approach, depending on the authentication strategy and also the platform constraints, because some strategies might be more, let's say, power and CPU, let's say, and CPU power consuming. Then the device connects to the bootstrap server to be provisioned with the initial configuration. And the last step is the device registering to the so-called device management server using a new session key and ready to operate. Of course, the personalization steps that we have described eliminates all the manual configurations and operations that are usually needed, simplifying and automating the management of critical information such as keys or identities, and this increases the security and reduces the exposure and human errors.
Okay, great. It actually looks like we have just hit the hour, so I believe that's all the time we have for today. Please be sure to check your inboxes in the coming days for the slides and replay link. And we do hope to see you during part 2 of this webinar on July 7th. You can find a link to register for that in the resources section. Thank you to Mihai, Martino, and thanks to all who joined us today.